Binomial distribution. Hey folks, we're going to be doing the binomial distribution. I'm going to teach you the long way, and then you're going to totally understand the concept, and then I'm going to show you the shortcut using the calculator. And that way you will totally appreciate the genius and magic of your calculator. I refer to this as 6.2. That's from another book. Just ignore that 6.2. This is binomial distribution. Okay. Hey folks, 6.2. We're going to learn how to use the binomial probability distribution function. This one right here. But we're actually going to use, this formula is in our calculator and it's going to be magical. But in order to really understand what's going on, I'm going to show us where this formula comes from and how to use it before I show you the magic shortcut of the calculator. So our example to get things going, let's talk about a basketball player named Shaq who doesn't make free throws very well. So the probability, P, that's central probability of making a basket, we'll shorthand P of B, is equal to 20%, 0.2. And either you make a basket or you miss a basket. So if there's only two possible outcomes, binomial. So some situations are binomial. There's only two possible outcomes. So in this one, it's binomial. Either you make a basket or you miss. So if the probability B, you make a basket, is 0.2, the probability that you miss M must be, they have to add up to 1. So this is 0.8. So you see how these two have to add up to 100%. So every situation, it's either this or that. It has to add up to 1. Okay. Okay, this is going to get a little complicated, but let's just go with it. Let's just try 2. Okay, so let's say Shaq attempts 2 shots. 2 shots. Okay, I'm going to make something called a tree diagram. So he either makes a basket B or he misses. So that's his first shot. Probability of a basket is 0.2. Probability of a miss is 0.8. Let's say he makes a basket. The next shot, so everything's always going to be 20% make, basket, 80% miss. So everything is always, we call it independent. There's no such thing as a hot streak or a cold streak. So it's always, the probability that he makes a basket is always 20%. So probability for the second shot, so let's assume he went down this path and he made a basket. On his next shot, he either makes a basket or he misses. Probability of making a basket, 0.2. Probability of missing, 0.8. Let's say on his first shot he had missed. Then on the second shot, he's either going to make a basket B or he's going to miss, M. And probability of making a basket is 0.2. Probability of missing is 0.8. So with this tree diagram, what we can see is he could have made a basket and then a basket and then a miss. See, I'm just going down the paths. A miss and then a basket, or a miss and then a miss. And the probability of a basket is 0.2 times 0.2. Go ahead and use your calculator. That's 0.04. A basket and then a miss, 0.2 times 0.8, 0.16. A miss and then a basket, 0.16. And then a miss and a miss, 0.64. And if I add up all those numbers, they have to add up to what? 1. Good. Because it's every possible situation. Okay. So, let's see. Let's make a little table of this. Number of baskets and the probability. So he's attempting 2 shots. So here's the tricky part. We always forget about 0. So 0, 1, or 2. If you attempt 2 shots, you can make none, you can make 1, you can make 2. Okay, what's the probability that he makes 0 baskets? 0 baskets is a miss and then a miss. Okay. Probability is that's 0.64. What's the probability of making 1 basket? 1 basket. 1 basket's a little bit tricky. It could be a basket miss or a miss and then a basket. So there's 2 situations in which he only makes one basket, right? Only one basket, only one basket. So if I add those together, I would get 0.32. And then number of baskets he makes is 2, probability of that, so that means basket, basket, so that's 0.04. And if I add these together, it has to add up to 1. Okay, cool. So they're going to ask us questions like this. So what's the probability that he makes probability of 0 baskets? So you would just sort of make this little table. We're not going to use the table. We're going to make we're going to use the calculator. But let's say we have the table. Probability of 0 baskets. That would be 0.64. Okay. Probability of, what if they got tricky? So instead of 0 baskets, they said something like 1 or more. 1 or more. 1 or more. So that's the 0.32. That's 1. So it's these two cases. So sometimes they get a little fancy. You could add those two together, or you could say 1 or more. Here's being fancy. So everything but this, so everything but the 0. So we know the total, everything has to add up to 1. So what if you did 1 minus the situations we did not include? That was tricky. That's going to give us 0.36. And you might say, well, wouldn't it be easier just to add those two up? Yeah, all roads lead to Rome. Probability, but let's see if we can do this. Probability of less than 2. Probability of less than 2. Okay, not 2, less than 2. So those guys. Okay. So in other words, everything but this? Oh, everything but that? What if I get fancy? 1 minus 0.04. Use your calculator, 0.96. Okay, and then you're probably saying, yeah, I got 0.96, but I just added those two together. I get you. I'm trying to get you to buy into this 1 minus trick. It comes in handy a lot, especially when there's more than just 3 situations. Okay, let's take a look at the worksheet. Are we ready for it yet? Okay. Let's try, let me do one more. Probability of 1 or less. 1 or less. Let me put a star here, put a star here. 1 or less. 1 or less is the one situation and the 0. So it's these two, and if you were to add them up, that would be what, 96? Okay. Let's redo these really quickly. The 2 blue ones I did on the calculator. Let's see if this is making any sense. Let me move this. Okay, so probability of 0 baskets. Maybe I didn't write it, but what if I said exactly 0 baskets? Okay, so if it's exactly, that's going to be the binomial PDF. So PDF, binomial PDF is when it's exactly 1 or exactly 2, or in this case exactly 0. Calculator on. Okay. Let's see. Ooh, distribution. So to get the distribution on my calculator, it's in blue above bars. So if it's in blue, I got to hit the blue button first. So blue, that. And then I'm going to slide down. It's way down there. What do they call it? Binomial PDF? Binomial. Oh, there's binomial CDF. No, binomial PDF. Okay, enter. Now, my calculator is not too fancy. Some of you, it actually asks you, it'll say, oh, hey, how many trials and how many, what's the probability and what's the X? So on your little worksheet, so check out worksheet 6.2, I kind of wrote what binomial wants. If your calculator looks like this, you have to give it an N, a P, and an X. So we need to give it an N, a P, and an X. So N is the number of trials. How many baskets did he shoot? It was 2, right? So put a 2 there. Comma is above 7, comma. What was the probability P? Probability P of making a basket, we said was 20%, put a 0.2. Comma, and we're interested in him making X how many? This case we said 0, so put a 0, end parenthesis, and it better say 0.64, enter, ta-da! Okay, cool. I put a little star next to this last one. So if it's a number or less, that's going to be the binom CDF. Binom CDF. And again, it's going to want an NP and an X. So if it's 1 or less, so it's the 1 and everything less. So it's going to add up everything. So it's going to add those two numbers together. So let's try it out. Let's go to distribution, slide all the way down. Oh, there's a shortcut if you go backwards. You go up, and then you can get to binom PDF. I think I saved half of a second. Enter. Give it the N, the P, and the X. N, right? We gave attempted 2 baskets, comma, above the 7. Probability P of making it was 0.2, 20%, comma, and we're interested in him. Oh, I meant to do CDF, son of a gun. Clear, okay. Distribution, CDF, enter. So CDF is going to look at the 1 and everything, I guess with I'd say below it, but that's confusing because I'm pointing up. It'll look at the 1 and the 0 case and add them all up. The 1 case and the 0 case. So if I had put 2 there, it would have looked at the 2, the 1, the 0, the 2, the 1, the 0, and added them all up. I'm rambling. Okay, so I'm going to give it the N, 2, comma, above the 7, 0.2, comma, and then for this one we want a 1, end parenthesis, and it better give me 0.96. Please work. Boom. Okay, cool. So now, let's take a look at what the formula actually means. So we had this. So the formula, so the calculator is actually doing this formula for us. The probability it's figuring out for us is NCX, P to the X, 1 minus P, the N minus X. And remember, this is all over the place. Remember how we got this value right here? There was one situation in which we made no baskets. So instead of, what if I instead put 2 times 0.16? Probably should have done that in the beginning. So there's one situation in which we make 0 baskets. There's 2 situations in which we make 1 basket. And then there's 1 situation in which we make 2 baskets. So you see that 1, 2, 1? You may recognize the 1, 2, 1 from the binomial. Okay, I've thoroughly confused everyone. Does it matter? We're going to use a calculator to get to the answer quickly, but let's just see if we can solve a problem using this formula. Let's make one up. So instead of Shaq, let's say it's a guy named Coco. And so the probability of Coco making a basket is 0.9. And the probability of missing would be what? Because it's binomial, it has to be 0.1. Okay. Let's say Coco attempts n equal 5 shots. And we're interested in the probability of making exactly x equal 3 of them. Okay, so let's see if this makes sense. We're going to use the formula, and then we'll use the calculator. Okay, the probability that Coco makes a basket is 0.9. Probability of missing, therefore, is 0.1. They have to add up to 1. So if Coco attempts n equal 5, trials is 5, n equal 5 shots, what's the probability that Coco will make exactly 3? Okay. So So the probability, therefore, is NCX. So of the 5, we're going to choose 3, right? The X is 3, the N is 5. The probability P of making a basket is 0.9. How many baskets did Coco make? X equal 3. Okay. What's the probability Coco misses? 1 minus P. Oh yeah, that makes sense. Probability of missing is 0.1. And how many did Coco miss? Well, if you made 3, that means you missed 2, right? 5 minus 3 is 2. Okay, so this is how many baskets did you attempt? 5. How many did you make? 3. Probability of make, 0.9. And how many did you make? 3. Probability of miss, 0.1. And how many did you miss? 2. Okay. You're going to appreciate the shortcut, but let's do this the long way. So 5, choose 3. That's that NCR we have. So go 5, math, PRB, NCR, 3. 5, choose 3. Enter. 10 times 0.9. Oh, to the third power. Do you know how to do something to the third power? You see that little arrow pointing up? That's called caret. Caret to the third power. Okay, slide out of that. Times 0.1 to the second power. Caret 2. Slide out and hit enter. And it says 0.0729. 0.0729. Okay, so now let's try this using Binom CDF or PDF. So Binom exactly 3. So Binom PDF, and we're going to have to give it the NPX. So that's going to be N was 5, the P was 0.9, and the X was 3. And it better give us 0.0729 if I'm doing this right. Okay, clear. Distribution. Sneaky way. Binom. PDF. Enter. 5, comma, 0.9, comma, 3, end parenthesis. Please work. Oh yeah. Oh yeah. Oh yeah. 729. Okay. So, we're ready to do the worksheet then, it looks like. Okay. Oh my God, it's already a 18-minute video. Okay, well, let's take a pause and then I'll just start a new video for the worksheet.